Bob Stevens.
Thank you, Mike, and thank you all for joining us today for the ASCE Texas Section webinar, Critical Infrastructure Assets, Part 2. I'd like to thank all of the branches that are hosting any viewing sites, and each of you again for joining us. As the State Association for Civil Engineers, we're happy to provide this service to the engineering community. If you're not a member of ASCE or the Texas section, I invite you to become a member so you can benefit from being part of this professional association. Now I'm pleased to introduce our presenter for today's training, Mark Williams, PhD, PE, SE. Mark is a senior principal and managing director in the diagnostic group at Walter P. Moore. He is also the practice area leader for restoration and renovation, where he brings an inclusive and collaborative approach to repairing, restoring, and upgrading the built environment. Dr. Williams has 23 years engineering experience in diversified aspects of structural engineering, analysis, design, repair, and management. He has been a member of ASCE since 1994. And now, Mark, go ahead with your presentation.
Thank you for that kind introduction there. The topic of today's webinar is structural inspection and condition assessment for critical infrastructure assets. This is part 2. For those of you that attended the first part that I gave a few months back, welcome back. For those of you attending for the first time, welcome. We did not have enough time in part 1 to cover all the different types of infrastructure assets out there. We picked 4 different ones off the ASCE report card. This time in part 2, we're going to do something similar. We're going to pick another 4 and go through those. By critical infrastructure assets, I'm talking about assets that are vital to the operation of the state of Texas, or even on a broader scale to the country as a whole. These are items that if they go down, they cause serious disruption to the operation of our infrastructure. Well, that's me. I work for Walter P. Moore in Houston, and my focus is on infrastructure assets. These days I'm working from home like many of you, I'm sure, but I do still find my way around the state and even beyond the state, looking at the various types of assets out there that keep our infrastructure going and functional. So the agenda for today, we're going to touch briefly on the ASCE report card. There's a 2007 report card out there. There's going to be a newer one soon, which is going to probably carry the 2021 label with it. We'll talk briefly about what makes up a grade on the scorecard, and the distinction between structural inspection and condition assessment. I'm a structural engineer, so my slant on looking at the report card, I'm going to be looking at different structural aspects of the different assets that are around. Certainly there are other things to be looking at as well. And lastly, we're going to talk about 4 different types of assets. So in this case, we're going to feature rail, aviation, ports, and wastewater. So the report card, this is the 2017 report card. There's a nice graphic and exhibit about it. The items that are circled here are going to be the ones of focus on this webinar. So aviation nationally gets a D. Wastewater nationally gets a D+. 2 other ones we'll be looking at are ports. Ports get a C+ on the national report card. And lastly, towards the bottom here, we'll be looking at rail, which gets a nice grade of a B. Clearly, there's still work that can be done with all these assets. It's probably not the report card you'd want to take home when you're a kid to your parents, but nevertheless, it tells us that we still have a lot of work to do to keep our assets in good order. If you look at the Texas infrastructure grades, this is state specific. You see the ones listed up here. Now, I mentioned aviation, I mentioned wastewater. I'm going to touch on those. Aviation gets a B- in Texas, wastewater gets a D. You'll notice that ports is not up here and rail is not up here, and they just weren't featured in the report card. We can get into that a little bit more. Doesn't mean we can't talk about them. They just don't have a prominent role in the state infrastructure report card. So what makes a grade? How do they figure all this out and give these grades to the various assets? There's a whole long list here of items, as you can see. There's capacity. Does the infrastructure meet the current demand? Future demands, there's condition. What's the infrastructure existing and near future physical condition? I've highlighted that one because it's going to be the subject of what we're talking about today. There's funding. What current levels of funding do you have from various agencies in order to support these assets? There's future need. What's going to be the cost to improve the infrastructure? The future funding prospects addressing the need. I've highlighted this one as well because it'll be a subject of today's discussion. And there's operation and maintenance. What's the owner's ability to operate and maintain the infrastructure properly? We've built a whole lot of infrastructure in this state and in this country. What do we do about maintaining and operating it? Lastly, there are a few more items here. Public safety, which of course is very important for these assets. There's resilience. They're going to stick around. Are they protected to prevent issues from occurring, threats and incidents and so forth? And lastly, innovation. What new innovative techniques, materials, technologies, and so forth could we implement to improve the infrastructure? So we're going to look at three aspects of this whole grading system here. That is condition, the future need, and the operations and maintenance. Look at the grading scale that ASCE has established, and A is exceptional, fit for the future. It sounds really great. I didn't see any A's scrolling through there, so it tells us we still have some room for improvement with our assets. A B is good, adequate for now. A C is mediocre, requiring attention. A D is poor at risk. And lastly, an F is failed, critical, unfit for purpose. We certainly don't want to be in the F, really don't want to be in the D. We'd at least be in the C and trending towards a B. But this is a way of establishing the condition of our various assets through a grading scale. I mentioned before, I'm a structural engineer, so that's my slant in looking at these assets. So I want to point out something in particular. It's maybe perhaps a nuance, but there's a little bit of a terminology thing here. And that is structural inspection is actually reviewing and documenting the condition of a structure. So you go out, you make a site assessment, you take field notes, you review it, you document all the distress conditions. That's the inspection process, documenting the current state. There are generally 5 different types of inspections. If you follow the bridge world, they kind of establish this first, and I'm going to sort of follow this through as we look at the different types of assets. That is, the first type of inspection is an initial inspection that's done when the bridge is first constructed. So you probably won't be doing that one again. It's just when you started out. Routine is what's mandated by federal guidelines or other regulations. How often do you have to look at the bridge, what frequency, and what do you have to record when you're looking at the bridge. In-depth is if you want to go a deeper dive into a particular inspection that was done. Say you want to do a load rating, or you want to look a little bit more analysis or detail into a particular bridge. There's a damage inspection, which, as the name implies, somebody ran into the bridge or damaged it in some way. You're going out there to assess the impact of that damage on the rest of the structure. And lastly, there's a special inspection. There are particular items that have been flagged or you want to follow up or look at on a routine basis, just one particular aspect of the bridge that is of concern. You could do a special inspection just to look at that. So again, this is coming out of the bridge world. There are 5 different types of inspections, really. I'm going to apply that same sort of rationale to the other types of assets that we're looking at. I'd say that the bridges are probably the most advanced or refined in terms of how they are reviewed and inspected and evaluated. And certainly the other assets we're talking about can follow suit with that approach. That was inspection. Now, condition assessment is the other term. So after you've gone out, you've inspected the bridge, you've documented everything that you see, distress and so forth. Condition assessment is the collection of all this information so that you can make informed decisions. And those informed decisions typically come around costs and budgets. That is, what is the most important item to take care of? Prioritization comes to mind as we look to take care of these assets. Management decisions come into play. So development, evaluation, testing new repair and maintenance techniques, corrective actions that need to be done, life cycle cost analysis, project budget priorities and scheduling, budgeting, long-term allocation, funding allocation, long-range planning. These are all management type decisions. So we have all of these assets. In many cases, we have way too many assets. How do we prioritize them? How do we group them and decide which ones we want to tackle first? So you have inspection feeding all this data to this process. Condition assessment is the decision-making process of ranking these, prioritizing them, and making the tough decisions with the limited funding that you have. So here's the Texas report card. This is tracked from 2004, 8, 12, 17. Those are the previous report cards. Again, a new one's going to be coming out soon. I've highlighted the ones we're going to be talking about today, which is aviation, ports, rail, and wastewater. You'll notice with aviation, it was trending better in Texas. So you go C+ to a B-, which is great. Nationally, not so good. We're sitting at a D. Ports were covered in previous report cards. It went D, D, C, and then the last report card was not reported, presumably because there's not enough of a concern about ports. They're not worried about the ports to report on it. Nationally, C+. Rail was not evaluated in the report card, but we're still going to talk about it. Nationally gets B, which is the highest, I think, if you look at the list. Yes, the highest on the list is rail. And lastly, wastewater. Wastewater has basically been trending a little bit down. It's C minuses and then to a D, nationally a D plus. So we got a lot of work to do on this. If you'll recall, the last time I gave this webinar a few months back, I featured 4 other assets, which were bridges, dams, drinking water, and energy. So we're hitting 4 more on the list. I'm almost running out of options after that. So part 2 may be the last one, but we'll see how this goes. All right, so let's jump into it. Let's talk about these different assets. The first one I've chosen is rail, and there are a couple of reasons why I'm doing that and introducing it first, in part because it has a great grade, and it doesn't have a lot of reporting in the statewide report card, but we'll talk about that. Nationally, $27 billion in improvements in 1 year by the freight railroads, basically highlighting the amount of expenditure to keep the rails going. So Texas Rail is a big question mark. You know, it's not in the report cards. Let's dive into that a little bit more. If you look at the numbers, so state of Texas, there's over 10,000 miles of rail. I don't know if that's a surprising number to you. It sounds like a lot to me, but their railroads are crisscrossing all over the state. There are 52 different railroad operators basically running within the state, which is quite a bit. And lastly, if we think about railroad bridges, again, I'm a structural person, so I'm going to talk about bridges here. There's 61,000 bridges in the U.S. Proportionally, I don't have the Texas number. I haven't been able to find it, but proportionally, Texas runs about 10% of the U.S. So just for sake of argument, there's probably about 6,000 railroad bridges in Texas, maybe a little less, maybe a little bit more. So we can talk about rail, but I'm going to focus more on what's carrying the rail, which are the bridges, railroad bridges in this state. And if you take a scenic drive around Texas, this is a rural area here, you'll see bridges like this. This happens to be a steel bridge. It's carrying rail. You can see there's a railing up on top, and just for transporting various items by rail around the state. It's a very common type of bridge to look at, not only the bridge, but the rails themselves in the inspection process. You also find that there are bridges that are meant for hoppers or just dumping or distributing material. So here's an example of one, steel bridge again. It's set up specifically in kind of an open state so that you can dump rail cars down to below and service them from there. And there are various other types of bridges for carrying railroad throughout the state. AREMA is kind of the governing body for railroad bridges. If you've come across that agency or codes before, I'm going to talk about railroad bridges in terms of how they would be characterized if they were highway bridges, but there are some tweaks to it because it's carrying rail. So if we go back to the guidelines set up by the Federal Highway Administration, basically the National Bridge Inventory Guidelines, they've set up various coding for conditions to evaluate bridges. And whether it's a highway bridge or a railroad bridge, you can basically consider them to be very similar. In those guidelines, they had set up different codes. NBI's National Bridge Inventory, the deck, which is up top, was given a code of 58, the superstructure code of 59, and the substructure, which is your walls or your foundations, is given a code of 60. And for each one of these items, you could go through a condition rating, basically establish the rating and then record that, and then that's going to be vital to the condition assessment process where you're trying to decide, prioritize what needs to be addressed first. So this is very much following just the bridge guidelines for highway bridges. There's a condition rating established, and I covered this in the previous webinar as well. We were talking about highway bridges. There's a rating system basically from 9 all the way down to 0. If you're a 9, as the green color indicates, you're in excellent condition. There's really nothing you need to do. Not many bridges get 9s. They typically get 8s when they start out because there might be something not quite right with them. But nevertheless, progressively as they deteriorate, they start dropping numbers in the ratings here. So you go from a 9 to an 8, it's very good condition. A 7 is good condition. Once you get to a 6, now you've changed colors here in this scheme. You're satisfactory. Some of the elements are showing minor deterioration at this point. A 5 is fair, where all primary structural elements are sound, but there may be some minor section loss, cracking, spalling, and scour. When you get to 4, that's the threshold for structurally deficient. So if you're structurally deficient, you're a 4 or less on a particular rating, whether that's the deck, superstructure, or substructure. A 4 is poor condition. You have advanced section loss at that point. And if you work your way down even beyond that, 3 is serious condition, 2 is critical, 1 is imminent failure, and 0 is failed. It's basically on the ground at that point or in the water. You certainly don't want to get it to that point. You want to maintain these and keep that condition rating going up. Over on the right are some suggested common actions for preservation and maintenance. So if you're in the green, the good category, the 9s, the 8s, the 7s, you're basically just doing a maintenance cycle. On a frequency, you're going out, maintaining the bridge, making sure all of the, if you have de-icing salts or other things that are being exposed to the bridge, they're cleaned routinely to keep the bridge in good order. When you work your way down to the 6-5 category in the yellow, you're doing preservation, you're doing condition-based maintenance. So there are going to be particularly things that are going to flag now that you need to do. So this is like concrete repair in order to get it back to where the bridge was before, or various types of steel repair as well. And when you get to 4 and below, again, that's the structurally deficient threshold. Now you're talking about rehabilitation or replacement. So replacement is bridge replacement, removing the whole thing, or it could be replacing certain members within the bridge. Say, for example, the deck needs to be removed and replaced, but you can keep the beams. There are various things that can be done. Now, in the context of railroads, this all can still apply. There's no reason why this could be any different. It's just that you're now carrying rails up on the bridge. You're not carrying trucks and traffic like you would with a highway bridge. So just to give you an example here, so this is just a typical bridge. You have the different components that are being rated over here in the left column. So you have the deck, superstructure, substructure. You may have some channel protection, culverts, roadway alignment, and traffic safety features associated with this. And then the descriptions are the different parts of the railroad bridge. So if it's the deck, decks are a little bit different with railroads. And in some ways, maybe they're a little bit more complicated. You have timber rail ties with the train rail. You have a reinforced concrete deck in this particular bridge. The superstructure is pre-stressed concrete. It also has some steel girders associated with it. Substructure has columns and piers and abutments and all that, channel protection and so forth. You look off to the right, you notice there's a rating for each one of these. So that's that 9 all the way down to 0. Just like for highway bridges, you can do it for railroad bridges. In this case, the deck is getting a 5. It's actually the worst part of the bridge. It's the part carrying the rail, which is of concern. It's given a fair condition. You're not quite structurally deficient, but certainly some action needs to be done. The other components here are rated 7s, and so they're generally good. In the average of things, this is a little bit misleading, but a 5 is not quite the average of 5s and 7s, but there's a little bit more I'm not showing you that's going into play to this. But generally, the bridge is rated fair because the worst part of the bridge is fair. You want to go ahead and raise the alert at this point that you're only as good as your weakest component in the bridge. And so in that case, this is the deck. And so it's carrying a 5 rating overall for that reason. Now, this worked pretty well for the bridge world for a while, but it turns out it's not quite granular enough. It doesn't get into enough detail about all the different components of the bridge. It simply just lumps them into deck, superstructure, and substructure. There's a lot more that you could document when you do an inspection about particular components, and maybe one component is deteriorated, but another one isn't. So there's ways to keep track of that. This all feeds into the condition assessment process at the end. So AASHTO came up with what they call the core, which is the commonly recognized elements, and that is they went element by element through a bridge and basically allowed you to give different conditions to every single element in the bridge. And those condition states go from 1 to 4. 1 being good. I know this numbering system is backwards in the condition rating scale, but bear with me. A 2 is fair, a 3 is poor, and a 4 is severe. Now this is on an element basis. And so common actions, if you're on a 1, you're just doing this cyclic maintenance. If you're doing a 2, now you're starting to have condition-based maintenance. There's a certain item you need to address on a regular basis. You get to 3 or 4, you have condition-based maintenance. You might be doing rehab at this point. You might even be doing replacement of this particular component. And lastly, when you get to 4, you're basically rehab replace. You don't want to get to 4 with any of these. Now I can pull out any particular element. So we're talking about railroad bridges here. So I'm going to pull out element 107. These are already pre-established in terms of rating. And that's a steel open girder or a beam. And it's measured in feet or meters if you prefer. And it's one of the national bridge elements. So why did I pull this one out? Well, railroad girders tend to be steel. They don't have to be. But I'm just using it for demonstrative purposes. You're going to quantify the amount of deterioration along that length, and you're going to put it in these different condition states. So how much of that beam falls into condition state 1, 2, 3, and 4, and that's going to help you prioritize what you need to do with the particular bridge. And so for steel, your items of concern or your defects are corrosion, cracking, fatigue, connections, and possibly load capacity. If you have concerns about its ability to carry the rail, the loading that's on the rail. And you can see definitions for the different states of corrosion, different states of cracking and fatigue, and so forth. But the goal here is to take each component of that railroad bridge and document how much of it falls into each one of these condition states. There's some various definitions as well and some feasible actions. So if you were in condition state 1, you probably wouldn't do anything but just protect it. If you were in 2, you may not do anything, protect it. Condition 3, probably getting that repair rehab. Of course, you can always do nothing if you're an owner. It's not a very wise thing to do sometimes. Lastly, condition state 4, you have the do nothing option, but more than likely you're going to be rehabbing and replacing. There's some definitions here for different types of distress, defects that you see, section loss and rust and so forth. If we look at an actual bridge, this is kind of how the rating shakes out when we're looking at a component-based level. So in this case, this table, we are looking at the deck. So again, the deck is carrying the rail of the bridge and whatever structural components are necessary to support that rail. You see, it's actually a pretty complicated list. If you think about a deck on a highway bridge, it's a concrete deck. A concrete deck takes vehicle traffic. You may have parapets or railings on the side and other things. This is getting a little bit more complicated here. You have the steel deck, which is the rail itself, quantified and in various condition. You have the timber deck and the rail ties, which are supporting the rail directly in various condition ratings, and they're done, in this case, each, whereas the deck is done per feet. And then you work your way down. You have a reinforced concrete bridge railing on this particular bridge. You have a concrete curb, steel deck, bridge metal railings, and so forth. You see each one of these elements being evaluated has a different number to it, and it has quantities, it has units that you would evaluate them in, and then you would put the units or the amount of particular item in each one of these condition states. So this looks fairly complicated for a deck. If I were to look at the superstructure, it looks a little bit better. This is what is the main structural system supporting the deck. You have various element numbers as well. You have the different types of structural components here. I talked about 107 before, which is an open girder steel beam. Here's an example of it. It happens to be 360 feet of it, and all of it is in condition state 2. Nothing in 1, nothing in 3, nothing in 4. And lastly, if I look at the substructure, there are various components that make up a substructure for a rail bridge. You have the abutments, which happen to be reinforced concrete in this example. You have pier caps, columns, piles, steel supports, and wing walls with reinforced concrete. They all have quantities themselves, either measured in feet or each or square feet, depending on what we're talking about. Each one is evaluated during the inspection process and quantified in the 4 different condition states. This seems like a whole lot of information that we're pulling here. Keep in mind, we're looking at the deck, which is carrying the rail. We're looking at the superstructure, which has all of its components, which is carrying the deck. And lastly, we're looking at the substructure, which is carrying the superstructure. So the load works its way down all the way to the ground. All of these are being quantified during the inspection process. They're being tabulated and pulled together. This is going to feed into the condition assessment process. So for every one of these rail bridges that you're looking at, you're going to collect all this data. Now the task becomes to try to prioritize and rank what's most important. And that's where this condition rating comes into play, is you look at condition rating and one other item that I'll show you in just a second here to help you make decisions about what you should address first. So if I look at what has been established in the bridge world, there's this nice pie chart. And basically what we're getting after is a condition rating. And this is part of the condition assessment process. How can we really tell how important this bridge is to repair? So what I'm suggesting here is, although it is a railroad bridge, you can follow suit with what's done for highway bridges and basically collect all this information, and let's come up with a condition rating number, and then we can rank those and then establish a threshold of how much we can actually get to at a given time, given budgets and funding. The formula is quite simple. Condition rating is just S1 plus S2 plus S3 minus S4. S1 is the structural rating. that is the condition rating coming out of looking at the bridge, that 9 all the way down to 0 for each one of the components. If you look in the bridge world, here's superstructure, here's substructure, culverts, inventory rating. S2 is your functional rating. That's the serviceability or functional obsolescence of it. There's a whole long list there of items for bridges. This can be modified for railroads because some of the items wouldn't be applicable here, but you would add other items in. And lastly, S3 is your essential use rating. That is, how important is this particular railroad bridge? Now, I started this out saying critical infrastructure assets, so there's kind of a hint. Yeah, they're all important. Yes, but how important beyond all important? This allows you to give some designation to how important it should be. And S4 is special reductions. Special reductions is in the bridge world for highway bridges, detour length, traffic safety features, the structure type, and so forth. Same idea can be applied for railroad. If you think about detours, how else are you going to get to where you need to get with rail if this bridge is taken out of service? So that comes into mind. It's a detour just like anything else. And it ends up being a reduction because they're so important. So the idea here is to sum up S1, S2, and S3, subtract off S4, and come up with your condition rating. If you are a 100, you are absolutely perfect. I haven't seen this number before, but suppose it could happen. If you're a 0, you're in critical condition. Again, you would take all of your railroad bridge assets and you could rank them based on the condition ratings, and then you could go down the list and establish a threshold to cut off of how many of these you think you can tackle at a given time. So like I said before, highway bridges and railroad bridges are really not that different. It's just you're not taking vehicle traffic on a railroad bridge, you're taking train traffic. But all the other things come into play. You're still inspecting it, you're still gathering all this data, you're giving a condition rating to it, and then you're putting this all on the hopper, looking at the pie chart here, and coming up with a condition assessment process so that you can rank and rate, see which ones are the most important to address first. I'll pause just for a second here on rail. Okay, now that we've gotten that out of the way, let's touch on our second asset, which is aviation. So on a national level, aviation gets a D, which is not good. And there's a note here, U.S. Airports serve 2 million passengers daily. I think that's pre-COVID, pretty sure, because it was 2017. I'm sure that number is way down now, but let's think about the future. Eventually this will come back, and we're going to be carrying lots and lots of passengers. Texas Aviation gets a B-, which is actually very good if you think about it on the way the report card and the scoring is shown. Just to give you sort of just a schematic here, some quick terminology when we talk about aviation, because aviation can mean many things when you're doing a condition evaluation. Again, I'm a structural engineer, so I'm going to look at this from the structural standpoint. I have options on this one. I can look at the terminal, for example. I know it's a building. I know it has a certain condition. It needs maintenance and it needs upkeep. And so I could go through and I can inspect the building, terminal building, and I could give a condition rating to that. I could also look at the automated people movers. So for example, if I'm at Bush Airport, IAH, or if I'm at DFW, Dallas-Fort Worth, they both have automated people mover systems. I could look at those as well from a condition evaluation standpoint because they are essentially bridge structures as well. They are just carrying a people mover on top of them instead of vehicle traffic or a rail, like for train cars. Or I have a third option here. And what I'm going to present today is I'm going to look at pavement. So I'm going to look at the pavement of the airport system and give condition ratings to it because it's equally important to all the other things I've mentioned. Just for terminology's sake, pavements are kind of divided into 3 different zones. You've got the apron and the ramp. That's where the planes park. That's where they go to the gate. When they get to the terminal, they're on the apron of the ramp. As they taxi in and out from the runway, they are on the taxiway, as the name implies. And lastly, when they get out to the runway for takeoffs and landings, they are on the runway. Just a little fun fact for you on the side here. I learned this somewhere along the way in looking at pavements. They keep track of the number of takeoffs for planes, but not the number of landings. And you can say, well, that's kind of silly. Well, the plane is so heavily loaded when it takes off, that is more important of a load and impact on the pavement than landing. You think landing, you're crashing the plane in to the runway and coming to a stop. That's actually less stress on the runway than a fully loaded plane driving around. So I picked that up somewhere along the way. Kind of an interesting little tidbit. Just talking a little bit more about pavements. I pulled this happens to be from Chicago. We can pull it from any other place in the country, but just to give you a sense of what makes up the pavements. Typically concrete on top, Portland cement concrete on the order of 16 to 21 inches. It's pretty thick. I've seen it even thicker than this in various pavements for airports. Sitting on an asphalt base, sitting on a permeable asphalt base, sitting on a lime soil base. So you add all this up, you're 40, 45 inches of pavement really, of different constituents. And rightfully so, it takes a lot of abuse. There's very heavy planes driving on here, landing, taking off and all that. And the runway itself takes a lot of abuse from the elements, as you can imagine. Well, you can do a condition rating system on airport pavements, just like the other items we've been talking about. It's a critical infrastructure asset, just like the others. If you don't have runways, you can't take off planes, can't move equipment around, can't move freight, people, and all of that. So it's a critical part of our infrastructure. Fortunately, the FAA has established a lot of what the defects are, the reporting procedures, and how we come up with the condition of airfield pavements. I'll show you excerpts from the federal FAA guidelines. This is coming out of the ASCE 150 and the 520 for pavement evaluation. They have a whole guideline on this. I'll just show you some of the defects. Map cracking being the first one. Map cracking, if you were to wad a piece of paper up and then unfold it, you have all these little patterns. They call that map cracking. There's polishing, where the aggregate is actually exposed and shiny in some cases. It's never a good thing. You have pop-outs, where the aggregate literally comes out of the surface, as the name pop-out implies. This is particularly concerning because when you are flying aircraft, landing, taking off, and so forth, there's the utmost concern about what they call FOD, which is flying object debris. You do not want to have jet engines suck any of this into the engines because it will damage them, and then there could be safety implications from that. So you're very much concerned when you have pop-outs and other types of distress in pavement. You do not want to be pulling any of that debris into the plane engines. Scaling, as the name implies, is the removal of the surface of the concrete. You can see the pitting that's occurring as a result of that. Cracking is cracking, concrete cracks. Joint spalling, you might have some unraveling at the joints. As you can see here, the little pieces of concrete debris, you don't want those going into engines. That's an example of FOD, or foreign object debris. Joint sealant deterioration, there are lots of panel joints on these pavements because they go for a long distance and they have to be jointed. Settlement, or heave, this is literally where one part of the pavement is moving different than the other. It could be up, could be down, depending on what the subbase or soil conditions are below. And lastly, faulting, where you're having entire panels of pavement dropping and creating these faults, or these lines here. That certainly is not good for travel on the pavement. As I said before, the FAA has already come up with condition rating guidelines, which is excellent. They have their own rating system, except it's not from 9 to 0 like it is in the bridge world. It's from 5 to 1, no problem. They spell it out quite well here, and it's all in terms of visible distress. I think that's very important to point out. If you're inspecting this, this is what you see with your eyes, but not necessarily with other equipment, which could be a follow-up inspection procedure. If you're 5, you're excellent. It's probably new pavement or recent rehabilitation that's occurred. It's less than 5 years old typically, so you're in the excellent category. If you're a 4, you have hairline or sealed cracks, 1/8 of an inch wide or less, map cracking, maybe some pop-outs. You're probably a little over 5 years old at this point, given the wear and tear. and minor spot repairs and crack and joint sealant repairs. This is maintenance items. That's that cyclic maintenance like goes on in the bridge world. Here it is occurring with pavements. If you're a 3, you're fair. You've got several broken into 2 pieces of slab, corner cracks, wider cracks. First sign of significant slab cracking, corner cracking, so forth is generally of concern. You get to 2, you got many slab cracks, larger cracks. You've got these D cracks going on, D regions, and there's various remedies listed there. And you get to 1, which has failed. You have just extensive deterioration with that. You're probably replacing the panel at that point, or you're looking at an overlay process of going over this with a very thick new concrete overlay. So as you can see, it goes from excellent all the way down to failed. You can imagine if you have this information, you go out and you conduct an inspection of the different parts of the airfield, whether that be the apron, the taxiway, or the runway. You can document what the condition of the panels are, of the pavement, using this rating system, and then that's going to feed into your condition assessment process. You have fewer airports to look at than you do rail bridges or other types of assets, but this is critically important that you get this rating right, because this is going to inform what you address first within the airport. So the condition assessment, I'm going to lobby to you that we should use the same process we use for bridges. That is that you can do a condition rating, and you simply add up S1, S2, S3, and subtract up S4. For airport pavements, what's S1? Well, it's a structural rating of the pavement. And so you would look at a condition rating of the runway, the taxiway, the apron. Like I said before, if you wanted to look at the terminal and do an assessment of that, you could. If you had an automated people mover, you can do an assessment of that. I'm sure you can come up with other parts of the aviation facility that you could do a condition rating and evaluation on. S2 is your functional rating, so what's affecting the function of the pavement? Well, you've got the cracking, polishing, pop-outs, spalling, failed sealants, settlement, faulting, all the things that I listed before out of the FAA pavement manual. And lastly, the essential for use factor. Well, this is a port of entry more than likely, so airports are pretty critical. So you're going to get your full 15 points in doing this, but there could be factors that affect that. And you're going to subtract off S4 from this, which is your special reduction. So in this case, the type of pavement may be redundant features, and you're going to rank all these up, and then you're going to set a threshold. And if you don't have a particular condition rating, then you're going to be prioritized and addressed first. So again, if you had 100, you're perfect, you're new. I haven't ever seen 100 before. If you have a 0, you're in critical condition. You can rank all of these particular elements of an airport or multiple airports and establish which ones need to be handled first. Obviously, if you got 100, you're good to go, but there's a threshold here, depending on your funds. You would draw the line and say, okay, everything below this needs to be addressed. Okay, so that is the very quick trip through aviation. Let me do ports. So ports nationally is a C+. 99% of America's overseas trade passes through ports. In case you didn't know that, it's a nice hefty number there. Ports are not reported in Texas. The presumption is that they're in good enough condition that they don't need to report on them. I'd like to hear other people's take on that as well at the end, if you'd like. So we'll get the question mark, but nevertheless, we're going to talk about it. Just to give you some numbers on this, there are 29 ports of entry in Texas. There are 16 seaports, if you didn't know that. They're plotted out on the map there, and there are 26 commercial airports. I just talked about aviation as a particular section. Well, it's also a port of entry, and it can also be considered a port depending on what you're talking about. If you take the Port of Houston, which is by far the biggest in the state, it is #1 in foreign tonnage for the world, #2 in US tonnage. So it's a very large port and receives a lot of traffic. There's various lines in between all these as well, connecting them and getting their freight from one place to the next. Ports always seem to be under construction, at least the ones I've dabbled with. Here's a good example of that. On the top, we're doing even more construction to accommodate cranes. You can see down the bottom, doing quite a bit of construction here around the bulkheads and so forth to accommodate different service. When they widened the Panama Canal, they had to do quite a bit of upgrades to Port of Houston in order to bring all that freight in. You imagine that the canal's wider, they get the deeper draft ships, and you have to do a lot of upgrades, heavier cargo, and so forth. Terminology is important with ports, and there's a lot of names thrown around. It gets really confusing really fast. Just to give you general names that are used, there's ports, harbors, wharfs, piers, jetties, quays, and landings. I'm showing you just a schematic on the right here of various parts of a particular port. It may or may not apply depending on which one you're looking at. You could have dolphins, which are helping direct ships so they don't damage the structure, wing walls, towers, aprons, transfer spans, bridge sheets, and trestles. It could look completely different if it's a wharf compared to what's shown here. Probably what's most important for the ports you might be looking at would be to look at it on a component level. And that is similar to the bridge world. You can break it into components: deck, superstructure, and substructure. The berthing system, the bulkhead, and the shoreline are probably the most important ones to look at when you're evaluating this. So for example, if we're looking at a wharf, and a wharf, we're looking at the underside. They're typically made out of concrete. They don't have to be. And we're inspecting it. We're probably on the water underneath the wharf doing this, or there's a platform down below, and we're doing an inspection, and we're looking at defects in concrete distress. So we have corrosion reinforcing steel, spalling, and we're quantifying for each element of this particular wharf structure, what is its condition. And so you can use the same condition rating process if you like, 9 all the way down to 0. And then you can go on an individual element basis, just as done in the bridge world, and give each one a more specific condition rating from 1 to 4. You identify all of those ratings, and you feed all that information into your condition assessment program. So in this case, we're seeing concrete spall, reinforcement, corrosion. Looking off to the right, there's quite a bit of, say, wear and tear and maintenance items that can be addressed. But generally, it's looking like it's in good condition. It just needs to have a little bit of repair on a maintenance program. So you can go element by element, and you can identify what the defects are and how much fall in each condition state. So I could take a particular part of the wharf we were just looking at, and I could document cracks, spalls, efflorescence if I had concerns about the load capacity. And I would take a quantification of that and put it in each condition state. Just like I showed you with the railroad bridges, you can do the same thing for a wharf. So you would have a certain percentage in condition states 1, 2, 3, and 4. And you would go element by element, and then you would feed all of that into an overall condition rating in order to inform the condition assessment process. Now, if it's like the Port of Houston and various other places, there's always a demand to upgrade. That is, you got bigger ships coming in, you got heavier cargo, larger cranes, and so you get the opportunity to do upgrades like this. In this particular case, the slab of the wharf is being upgraded and strengthened in order to accommodate new cranes that are coming through and new freight. Excuse me. In the second case, this is carbon fiber strengthening that's occurring in order to upgrade the beams of a wharf in order to take more capacity for gantry cranes that are coming through. You can see some of the corrosion occurring on the reinforcing steel here. Okay, so same process applies for ports. Again, it's very widespread. There's lots of different parts of a port. I just chose to show you wharfs, for example, but generally you'd follow the same condition rating process. Condition rating is S1 plus S2 plus S3 minus S4. S1 is your structural rating, S2 is your functional rating, S3 is your essential rating, and then you subtract off any special reductions. For a port structure, you might be looking at deck, superstructure, substructure, berthing system, bulkheads, and protected shoreline as your condition rating items if you're structural. In terms of serviceability, we're looking at cracking, concrete cover, corrosion, spalling, and load capacity. Essential use, it's a port of entry, so yeah, it's probably pretty important to keep it going, but there could be cases where it's not being used as much as some other parts of the port. You simply add up the S1, the S2, and the S3. Special deductions could be the type of structure, the type of port that it is. Is it out of concrete? Is it steel? Is it timber? You know, various types of building materials, and then what safety features are in there to protect it from impact from ships, for example, would weigh into the condition rating. A perfect score is 100, a 0 is critical condition. You would rank all these particular parts of the port, establish a threshold that if you get below that, then you would have to take care of it in a prioritized manner. That's all part of the condition assessment process, just like we talked about with the other assets. The last one I'll talk about is wastewater. It's kind of switching gears here. I'll talk about ports. No implication here in wastewater. They're unrelated. Nationally gets a D+. And there's a note here. It says demand on treatment plants will grow more than 23% by 2032. So there's a lot more demand, a lot more people using and generating wastewater. Texas wastewater, not so good, a D. You know, its national average was D+, or D, actually worse than the national average. Here's your typical wastewater treatment plant in Texas. You've got various tanks being used as part of the process of treating wastewater before the water is returned back into service. You might have aeration tanks, like what's shown here. This is all being stirred around in order to aerate it as part of the biological process that breaks down all the sewage and sludge. And you might have clarification tanks as well, where they're spinning around in order to clarify the water. Just to give you an example here, let's talk terminology just for a minute. So if we're going to go and evaluate and inspect this, and we need to establish what the different elements are that we're going to be rating. So in this case, for a clarifier, we have the rake arm, we have the basin slab, which is typically concrete, basin wall, typically concrete, support column, drive platform, and railing. During the inspection process, you'd go through each one of these and you would assign a condition rating to it, very much like what's done for the other assets. And you would keep your detailed notes. If you wanted to go to a more detailed element basis, you could, using the same premise as the other assets here. You could go element by element. And let's take the basin slab, for example. You could note the defects that are in the basin slab. You have cracks, spalling, delamination, effervescence, or some concerns about load capacity of the basin slab. It would fall into different condition states depending on the severity of what you saw. You would quantify each one. So for the cracks that you saw, how much fall into condition states 1, 2, 3, and 4, or other types of defects that are here. And all that information would be fed into the condition assessment process. So you can imagine, you could take this as far as you really want to. You could go on a tank by tank basis. You could go within a tank and you could look at the particular items and quantify them. All depends on the, I guess, level of detail investigation that you want to do. And whether you're considering this a routine inspection, an in-depth inspection, depends on the type of inspection occurring. I suppose there could be damage as well if you're going back and inspecting that. But nevertheless, you're going to sum all this up. And just like the other ones, I'm going to suggest that you follow the same process here, which is you establish a condition rating for the wastewater treatment plant. Again, I'm looking at the structural parts of this. You could certainly make an argument for the water and the treatment parts of this and various other parts of the plant that might be of your interest. And you could establish a rating scale in a similar manner. S1 are your structural ratings. So your structural components in this case, if we're talking about the clarifier tanks, basin slab, basin wall, support columns, the rake arm, you may have a baffle wall, driving platform, and railings. And you would give condition ratings to each one of those items. If you're talking about the functional rating, similar to other things with concrete distress, you could have cracking, concrete cover, joint issues, tank capacity issues, chemical process issues, whatever you want to feed into the function and serviceability of that particular tank. As far as it's essential for use, well, it's being done for water treatment. Generally, that's very important, but there could be instances where it's not super critical that this plant could actually come offline for a little bit. But generally, they're running at capacity and need to be used, and they're essential to the operation of the infrastructure. And lastly, there are some special reductions that could be had. The structure type and the safety features that are involved with this. The percentages here are arbitrary. You know, these are set up for bridges, the 55% and 30 and 15 and subtracting off 13. You could certainly come up with your own system. You may have a local owner operator who has their particular preference for numbers and ranking. Sure, no problem. It's certainly up to you and your judgment when you're evaluating these. But the end goal is to add up all these numbers. 100's perfect, 0 is critical condition. You would rank them. So you, in this case, for a water treatment plant, you could rank the different parts of the plant if you wanted to, or you could rank different plants and come up with a prioritized system, rank the condition ratings, establish a threshold based on the funding and the dollars that you have and what's budgeted, and then anything below that needs to be addressed in a timely manner in order to get it operational and functional. You certainly don't want to lose this asset. You don't want to take it out of service, just like any other asset that I've talked about. They're all critical to the operation of the infrastructure. So I will leave you with this slide here, and this is just a reminder of what the current report card is for Texas. So we talked about aviation, we talked about rail, we talked about ports, we talked about wastewater, and previously we talked about 4 other items. Like I said, we're running out of items to discuss, but just wanted to raise the awareness of where we sit in Texas as far as the report card goes. And as I said, the report card is going to be revised here soon. We're going to see a new report card so we can start this process all over again. I'm hopeful that our letters are going to improve, but we will see where we stand. So with that, I thank you. I'll leave the rest of the time for questions. I assume there's some in the Q&A box, and I'm happy to field them.
All right, Mark, thank you. The first question is concerning the wastewater. Does it mean that it needs a lot to be done for making it safe disposal of wastewater?
Yes, I would suggest, this is somewhat my bias and interest is on the structural side. So on the structural side, they're generally in good condition. That's not the main concern. The main concern is more on the water treatment and processing side of wastewater. And I'll leave that to other experts to opine on.
All right, thank you. And the next question is the revenue generation has higher weight, or the exposure to the public has a higher weight for the current good or bad rankings?
Yeah, great question. It's so hard to predict. Generally, we don't get a lot of press as engineers until something goes bad, something goes wrong, and it's portrayed in a certain way in the media. And that could be slanted, skewed, or whatever it happens to be. And so in that given moment, it's critical because life safety is going to be played up to no end. And then at other times, dollars are important as well. I don't know. That's a great question. I don't have a really simple answer for it, but they're both important and they're both very situational at the times.
And one other question on a similar topic. Have you seen anything recently about the electrical system in the power electrical grid in the United States coming out of ASCE?
In the part 1 that I gave, I talked about energy, and I chose to focus on cooling towers, which are just one part of the power production. But the ASCE report card for the state of Texas was actually very favorable for energy. In fact, they chose not to give it a rating because they felt that it was in good condition. So I think in Texas, we're in great shape. I think we have our own grid, so to speak. We're doing well. Other parts of the country, probably not as good. You're definitely seeing a change from coal to natural gas with prices being so cheap. And in some cases, you're seeing power plants being decommissioned because of demand actually going down, which I find interesting. Even though we're adding population and we're adding gadgets and all these things, in some cases, demand is actually decreasing in some parts of the country.
And there's one more question. Does the wastewater rating include transmission mains and collection lines delivering the wastewater to the plant?
Great question. You could certainly take this as far as you want. The ones that I've looked at specifically the plant. Although, yeah, you could take this as far back as you want. You could also make the argument on energy. You could take the transmission lines back as far as you want, and you could really map out the entire infrastructure. It's really a question of how far the extents you want to take this in terms of the evaluation.
All right. Well, thank you very much. Mm-hmm. And there's one more just popped up. Okay. Who certifies this report card?
Who certifies the report card? I don't know. ASCE puts it out as an informational piece to raise the awareness about the state of the infrastructure. So I'm guessing the question is asking about ASCE's effort, not my particular effort in looking at a project.
Yes, I assume that's what it would mean. It's,
Okay.
of course, all the engineers that participate in the evaluation, and the cumulative results are what are presented in the report. Okay. Seeing no further questions.
All right.
I want to thank you very much again for giving us a very insightful presentation on the state of infrastructure in Texas and how ratings are done. Again, thank you all for participating in hearing Mark's presentation. As mentioned before, individual registrants will receive an attendance acknowledgement without any further action. And if you're in a group, the site coordinator will receive the attendance acknowledgement for distribution. If you're interested in presenting a Texas Section webinar, please contact office@texasce.org for more information. You can visit the webinars page on the ASCE Texas Section website for a full list of upcoming sessions, including Project Management 101, which will be October 13th, and Risk Management for Underground Construction on November 10th. We're always available for your questions and hope to hear from you soon. And draw your attention to the upcoming announcement for the virtual CECOM, November 4th to 6th, as the in-person one in September has been postponed to a virtual one in November. So look for that announcement, and please consider participating in the virtual CECOM. Thank you very much. And Mike, I turn it back to you.
All right. Thank you, Bob. Thanks, everyone, for attending, and thank you, Mark, for presenting. Before we conclude the session today, we had one more question come in. I know we're pushing our time here. But Mark, what are the criteria for contractor choice after assessments are completed?
Mm-hmm. Great question. Many of these, I'll call them municipal type projects, because that's who owns a lot of this infrastructure. They either have their own screening or qualification guidelines for contractors, or if they don't, we generally push for that because we want to get the best qualified contractors involved. But you're definitely looking for work experience with this and in handling the disruption to the infrastructure. That is, if you're going to repair this, you're going to have to take a certain part of it down to do the repair. Who is best versed at scheduling, phasing, and taking down parts of this in order to very quickly do the repairs and get out of there? Schedule drives everything with this, more so than dollars, I would say.
All right. Thank you very much. Thanks again to all of our attendees. We hope you enjoyed the presentation and got something out of it, and enjoy the rest of your day.